Hello everyone, welcome back. So this is our video lecture 3 for the chapter number 6 class 8 mathematics. And now we are going to learn about some more interesting patterns. This is our part 2. Let's begin. First of all, we are given a sum of consecutive natural numbers. So if we let a number be n square, which is actually, what is this n square? This n square is actually the square of an odd number n. Then it can be expressed as the sum of two consecutive positive integers. And that first positive integer will be n square minus 1 by 2, and the consecutive second positive integer will be n square plus 1 by 2. This will be clear when you do an example. Now for example, we have 9. Now 9 is the square of 3, we know that. It is the square of this odd number, that is 3. So 3 square equals to 9. And 3 square equals to 9. 9 can be written as the sum of two consecutive positive integers, that are, which two positive integers are those? Consecutive positive integers 4 and 5. 9 can be written as the sum of 4 and 5, that is 4 plus 5. How can we find those two positive integers? We know that the formula for the first number will be n square minus 1 by 2, and for the second number it will be n square plus 1 by 2. These will be the two consecutive positive integers whose sum will give us that square. So since here n square is 9, so 1 will be the n square minus 1 by 2, that when calculated gives us 4, and n square plus 1 by 2 gives us 5. And we know that 4 plus 5 equals to 9. This is how you find. Let's do some more. Let's try these questions. Express the following as the sum of two consecutive integers. The first one is 21 square. So for the first part, I will do it for you. It is 21 square. Now we know that the first such integer will be n square minus 1 by 2. That is 21 square in this case, minus 1 by 2. That is going to be 441 minus 1 by 2. That is 440 by 2. That is 220. And the other one will be n square plus 1 by 2. Second integer will be n square plus 1 by 2, that is 441 plus 1 by 2. 441 plus 1 by 2, that is 442 by 2, or you can write it as 221. You can directly add 1 here and you will get these two consecutive integers because they are consecutive, so you will add 1 to this. 220 and the other one is 221. So for this, it is the sum of 220. The sum of this 20, the square of 21 is 441, and 441 can be written as the sum of two consecutive integers. What are those two positive consecutive integers? 220 and 221. Similarly for 13, I will do now 13 square. For 13 square, second part, here I am writing it. Now for the second part, that is 13 square, one number will be, the first one will be equal to 13 square minus 1 by 2, writing it directly. 13 square is, yes, what it is? It is 169. Therefore, 169 minus 1 upon 2, that is equal to 168 by 2. You can write it as 84. If one is 84, the other one will be 85. So, 13 square, that is 169. It can be written as the sum of two consecutive positive integers, and that are 84 plus 85. You can check it by adding these two numbers, you will get 169. That is the square of 13. Other two are going to be done just in the similar way. Do this yourself. Have a practice for solving such questions. What does the second part say? Now, second part is asking that, do you think the reverse is also true? Now, for this statement, is the reverse also true? That is the sum of any two consecutive positive integers is perfect square of a number? Is it so? Give example to support your answer. So, it's asking that we know the opposite is true for this case, but is the reverse also true? This question is asking that, is the sum of any two positive consecutive integers a perfect square of a number? Let's take 6 and the other 5, consecutive positive integer 5. These two are consecutive positive integers, 5 and 6. But what if we add these two? 5 plus 6 gives us 11. But is 11 a perfect square? No, 11 is not a perfect square. So we can say that this is not always true. This is not always the case that the sum of any two consecutive positive integers will give us a number that is a perfect square. This is not always true. So no, and here I have given you an example like 5 plus 6 gives us 11 and 11 is not a perfect square. What is the next topic? Next one is product of two consecutive even or odd natural numbers. Now, till now we were studying about the sum. Now we are learning about product of two consecutive even or odd natural numbers. So, if we have a plus 1 that is multiplied with a minus 1, then the formula becomes a square minus 1. For an example, take 11 into 13. We know 11 into 13 gives us 143. That can be written as 12 square minus 1 because 12 square is 144. 144 minus 1 gives us 44 minus 1 gives us 143. Yes, it's correct. 11 to 13 is 143. That can be written as 12 square minus 1. Also, 11 into 13 can be written as 11 can be written as 12 minus 1 into 13 can be written as 12 plus 1. So, therefore, 11 into 13 can be written as 12 minus 1 into 12 plus 1, or we can write it as 12 square minus 1. The same. So, this is how we proceed for such numbers. Similarly, let's do these questions. 13 into 15. So 13 into 15 can be written as, we know that 13 into 15, we can write 13 as 14 minus 1 into 15 can be written as 14 plus 1. Therefore, this whole number can be written as 14 square minus 1. Similarly, 29 into 31, we can write 29 as 30 minus 1 into 31 as 30 plus 1, that is 30 square minus 1. This one as 44 into 46, 44 can be written as 41 minus 1. 46 can be written as 45 plus 1. That is, this whole number can be written as 45 square minus 1. And this is in the similar way I have written as in this form, these numbers in this form. This is how you write the product of two consecutive even or odd natural numbers. This is how you do it. Some more patterns in square numbers. There are some more patterns in square numbers, very interesting patterns. You can observe these squares of numbers 1, then 11, then 111, like adding one more number and doing the squares is in this form. This is just an interesting way, some more pattern in square numbers. Next up we have one more pattern. Another pattern is like 7 square is 49, we know that. 67 square is 4489. Now 667 square becomes 444889. So, if we are adding one more 6 and doing the square of that number, we are going to add one more 4, one more 8. One more 4 and one more 8. This is how you do it. This is one more pattern you can see in the square numbers. Write the square making use of the above pattern. So, here we are going to use, here you will be using the same patterns that were given to find the squares of these two numbers. So, here we have 1, 1, 1, 1, 1, 6 times and doing that square. You can do it using this pattern. Just following this pattern, you can do this question. This is just a fun question. Do it using the previous patterns. Now here you can just read how many, see how many 11s, how many 1s are there, and then using the previous pattern, you can solve it. Write the square. Similarly for this, I've told you how this pattern works. If we add one more 6, we got to add. See from here, we got to add 4, one more 4 and one more 8 to the number. So this is going to be using that pattern. Just solve these two questions. Now next one is important, finding the square of a number. So see, squares of small numbers, we know that the squares of number like 3, 4, 5, 6, 7 and so on, these small number square can be easily calculated. Easy to find. But finding the square of 23 is not easy and quick. Yes, we know in order to find the square of 20, in order to find the square of 23, how are we going to do? How are we going to find the square of 23? We have to multiply 23 by 23. That is going to be a cumbersome process. That is not going to be very easy and quick. Just like the finding the squares of number 3, 4, 5, 6, 7 and such small numbers. But there is one more method, that is finding the square of the numbers without actual multiplication. So how does this happen? I'll do one, do the other yourself. I'll tell you, I'll teach you this method. So if we are asked to find the square of any number without actual multiplication. How do we do it? So like 39, you know that 39 can be written as 30 plus 9. We have to find 39's square. This is not going to be easy because we have to multiply 39 with 39. That will be a huge calculation, not an easy one. 39 square will be 30 plus 9 whole square. This can be written as 30 into 30 plus 9 plus 9 into 30 plus 9. Right, you can write this thing as this, which can further be written as 30 square plus 30 into 9 plus 9 into 30 plus 9 square. Opening these brackets, you can write this as 30 square plus 30 into 9 plus 9 into 30 plus 9 square. Now the squares of 30 and 9 are easy to find. 30 square will be 3 3 is 9 and 1 0 will become 2 0. This is 270, this is again 270, just the same number, interchange positions, and 9 square we know that it is 81. We can easily add these four numbers, 900 with 270 and 81. Do it in your rough circle. You will find that it is going to be 7 and 7, 14 and 14 and 8 are 22. 14 and 8 are 22. So it is 9, 10, 11, 12, 13, 14, 15. So the answer is 1521. 1529. What is this? This is what we had to find. That is the square of 39. 39 square. It comes to be 1521. And how did we solve it? We solved it. We found out the square of this number 39 without actual multiplication. But what if we actually multiplied? Then we have to find this. So let's just check, are the answers coming to be same? This is 1521 again. So this was the method how to find the squares of the numbers without actual multiplication. So I'll show you how you have to do it. You are going to do 40 plus 2 and find the square of this. Again, you have to write it as this. After this step, you have to then open up the bracket and solve these easy squares. And then finally add the numbers that you get. This is how you do it. Do the second part yourself. Next up, we have finding square of a number with unit digit 5. So there is actually a formula for finding the square of a number, such a number that ends with the digit 5. So a number that has the unit digit 5, that number square can be easily found out with the help of a formula. What is that formula? See, consider a number with the unit digit 5 and that number is actually A5. A can take any value. There is this A at 10's place and at the 1's place there is 5. Unit digit is 5. Now what is going to be the square of this A5? The square of this A5, this is how you solve it, and what do you get? You get, see, this is the previous method only, that how we solve it, but the final formula that we get for the square of finding such a number that ends with the unit digit 5 is given by this formula, that if the number is A5 and we have to find its square, the formula to find that square will be A into A plus 1, 100 plus 25. Let's do an example. Here we have 25 square. So we need to find the square of 25. We just saw that this number 25, it ends with the number digit 5. It has unit, the digit at unit's place is 5. So there is a formula to find the square. That is an easy formula. What is A here? A is 2. So the formula is A into A plus 1 into 100 plus 25. That will be 2 into 2 plus 1, that is 3 into 100 plus 25. That is 2 3 is 6, 600 plus 25 and its answer is 625. You can check this, you know this. You should actually remember some of the square numbers. So 25 square is actually 625. And how did you solve it? You did not multiply 25 with 25, but we had a formula for this such numbers. We have a formula for such numbers. that end with 5, and that formula is a into a plus 1 into 100 plus 25. Then you solved it, you got 625, which is actually the square of 25. Remember this formula. Let's apply this formula in finding the squares of the given numbers, because all of these numbers, you can see that all of these numbers, they end with the digit 5. How do we proceed? Here we can check that since for the first part, this number is 15. What is a here? A is 1. Formula will be, so 15 square will be a into a plus 1 into 100 plus 25. That is a is 1 into 1 plus 1 is 2 into 100 plus 25. That is 200 plus 25. That gives us 225. And yes, 225 is the answer, because we know that 15 square is 225. How we found out? We found out using the formula for this, finding the squares of numbers that end with 5. Use the same formula to find out the answers for these 3 parts as well. So just use this formula, proceed in the same manner that I did for these 2 examples, and find out the answers for these values. So you have to just leave 5, and the other number that you're getting is your whole a. So here a will be 10, here a will be 20. This is the same as this. A will be 9. A into a plus 1 into 100 plus 25. Use these formulas. Find the answers for these 3 questions. You can check these using calculator. You can directly multiply this number with itself to find out whether your answer is correct or not. Next comes Pythagorean triplets. So what does this say? That for any natural number m, say there is a natural number m that is greater than 1. We have 2m whole square plus m square minus 1 whole square, that is equal to m square plus 1 whole square. So these 3 numbers, that is 2m, m square minus 1 and m square plus 1, they form a Pythagorean triplet. So what are the Pythagorean triplets? Pythagorean triplets are the 3 numbers that are of the form, which form 2m, m square minus 1 and m square plus 1. So these 2m, m square minus 1 and m square plus 1, if these 3 numbers, they just justify this condition, then these 3 numbers form a Pythagorean triplet. Example, you can see here 3 square plus 4 square is equal to 9 plus 16. That is 25, and 25 is actually 5 square. So the collection of these numbers 3, 4 and 5, these can be called as a Pythagorean triplet. So Pythagorean triplet are the numbers 2m, m square minus 1 and m square plus 1. We have questions related to it. First example number 2, write a Pythagorean triplet whose smallest number is 8. So we know that in this case, when the Pythagorean triplets are 2m, m square minus 1 and m square plus 1, the smallest is 2m. So we are given smallest number is 8, that is 2m equals to 8. What is our m? M is equal to 4. So m we have got. What will be the other member of the Pythagorean triplet? It will be m square minus 1. So first is this, second will be m square minus 1, that is 4 square, that is 16 minus 1 is 15. And what will be the third one? Third one is going to be m square plus 1, that is m square again 16 plus 1, that is 17. And these numbers, so the Pythagorean triplet is, what is the Pythagorean triplet? The Pythagorean triplet that has 8 as its smallest member is 8, 15 and 17. This is our such Pythagorean triplet, 8, 15 and 17. One more example related to it. Find a Pythagorean triplet in which one member is 12. So we are not given that 12 is the smallest member or 12 is the largest member of that Pythagorean triplet. We just said that one of the members is 12. Let's see if m square minus 1 is 12, because we know there are 2m, m square minus 1 and m square plus 1 that form this Pythagorean triplet. If say m square minus, let m square minus 1 equals to 12, that gives us m square is equal to 12 plus 1, that will be 13. But we know that there is no such m for which m square will be 13. So this is not the case. We cannot take m square minus 1 as 12. Now let us take in the second case case, let us take m square plus 1 equals to 12. That will give us m square is equal to 12 minus 1, that is 11. Now again, there is no such m for which m square will be 11. So this is again not right. Now the last one left is 2m. Now let 2m is equal to 12. Then m will be 6. So we have got m. This is our first member of the triplet. Now if m is 6, we can find m square minus 1. That will be 6 square. 36 minus 1 is 35. Second one will be this, and third one will be given by m square plus 1. That is m square 6 square 36 plus 1 is 37. This will be our third member. So what are those? What is that Pythagorean triplet? Which are all the three members? One is 12, the other one is 35, and the last one is 37. So this is a Pythagorean triplet that has one of the member as 12. This was all about this video section. We learned a lot of things in it, and in the next video we are going to learn about finding square roots. The methods to find square roots. Okay, we'll meet in the next lecture. Thank you.